Why is frequency response vital for electrical transfer functions? Have you ever wondered how electrical systems respond to different signals? Understanding this is key in electrical engineering, especially when we talk about transfer functions. So, why is frequency response so important for these functions? Let's break it down. Frequency response describes how a system reacts to various input signal frequencies. It shows how the output changes in both amplitude and phase as the frequency varies. This is essential for engineers to predict how circuits behave under different conditions. In electrical engineering, a transfer function connects the output of a system to its input in the frequency domain. This function is complex and captures both the gain and phase shift introduced by the system. When we evaluate the transfer function along the imaginary axis, we get the frequency response. This represents how the system behaves with steady-state sinusoidal inputs at different frequencies. One reason frequency response is vital is that it provides a complete description of how a circuit processes sinusoidal inputs. It tells us how the output amplitude and phase change relative to the input. This is particularly important for analyzing circuits like filters and amplifiers, where frequency-dependent behavior is key. Engineers also use frequency response for design and analysis. It helps in creating circuits that meet specific requirements, such as desired bandwidth or gain. In control systems, analyzing frequency response allows engineers to assess system stability and performance by looking at gain and phase characteristics across frequencies. Another benefit is that frequency response simplifies complex systems. Instead of using differential equations, engineers can apply algebraic methods to analyze system behavior. This is especially useful for cascaded systems, where the overall response is the product of individual frequency responses. This approach makes design and analysis more manageable. In practical applications, frequency response plays a significant role in signal processing. It guides the design of filters that either pass or reject certain frequency bands. In audio engineering, it ensures components produce a flat response to minimize distortion. In control systems, it helps tune controllers for the desired dynamic responses. Lastly, examining frequency response plots allows engineers to identify resonances, bandwidth limits, and phase delays that impact system performance. This information is vital for making informed decisions to improve or modify circuit behavior. In essence, frequency response is vital for electrical transfer functions because it provides a clear picture of how circuits and systems behave with respect to frequency. This understanding enables effective design, analysis, and optimization in electrical engineering.